Have you ever wondered how your favorite apps just seem to read your mind? Well, today, we're going to peek behind the curtain at the hidden architecture that powers those eerily accurate recommendations. I promise you, it's not magic, and we're about to see exactly how it all works. No, really, just think about that for a second. You're scrolling through an app, minding your own business, and boom, it suggests something a friend of a friend just bought. How in the world does it connect all those dots, practically in the blink of an eye? The answer, it turns out, is a really elegant piece of engineering. So here's how we're going to break this all down. First, we'll dive into the two completely different worlds of data at the heart of the problem. Then, we'll look at the big choice every architect has to make. After that, we'll uncover a really clever trick that makes the whole thing possible. And finally, we'll see how it all comes together to build the smarter web you use every single day. Okay, so to really get the solution, you have to appreciate the problem. And that seemingly simple question about what your friends' friends like, well, it actually creates a massive headache for developers. It forces them to pull information from two totally different data universes at the exact same time. Think of it like this. On one hand, you've got what we'll call the biography. This is your document database. Each document is like a rich, detailed profile card for one specific thing, a user, a product, you name it. If you want to know everything there is to know about one item, you just pull its biography off the shelf. Super simple. But then, on the other hand, you have the relationship map. This is a graph database. It couldn't care less about the details. It's all about the connections, who's friends with whom, who liked what product. It's the perfect tool for exploring a network. So it's pretty clear you absolutely need both, right? You need the relationship map to find the connections, and you need the biographies to get the details. And this brings every single architect to this huge fork in the road. How do you possibly juggle these two separate worlds without it all turning into complete chaos? And really, it boils down to this classic question. Do you try to find one single database that can kind of do both jobs okay? One system to rule them all? Or do you hire two separate, highly specialized experts, one that's amazing with documents and one that's a genius with graphs, and just figure out how to make them work together? This table really lays out the trade-offs. Now, that unified approach, it seems simpler up front, but it's a compromise. It's a jack of all trades, master of none, and you can't scale one part without scaling the other, which gets really wasteful. The polyglot approach, though, using two specialists, that's where the real power is. You get the absolute best tool for each job, but, and this is a big but, it creates a whole new massive headache. And this is the million-dollar question, isn't it? If you update a user's profile in the biography, how do you absolutely guarantee that the relationship map gets that exact same update? Because if one works and the other one fails, your data is now inconsistent, and that is a recipe for total disaster in any big app. So how do the pros solve this puzzle? Well, they use this wonderfully elegant solution called the Outbox Pattern. This is the clever little trick that lets them have their cake and eat it too. They get all the power of two specialized databases without any of the risk of them drifting apart. Okay, so here's the core idea, and it's brilliant. When a user updates their name, you don't just change their biography. In that exact same single unbreakable action, you also write a little to-do note. This note just says, hey, just so you know, this person's name changed. And that little note goes into a special box, the Outbox. This flow shows it perfectly. Step 1, the change and that to-do note get saved together. This is what engineers call atomic. It means it either all happens or none of it happens. You can't get one without the other. Step 2, and this is key, the user immediately sees a success message. Then, behind the scenes, this little worker bee process comes along, checks the Outbox, finds the note, updates the relationship map, and then marks the task as complete. It's an incredibly reliable system that guarantees the two databases will eventually get back in sync. All right, so we have our two specialized systems, and we have our clever trick for keeping them in sync. So now let's put it all together and see how they team up to answer that impossible question we started with. It's a beautiful little dance called a hybrid query. First, the app goes over to the relationship map. It asks, hey, can you quickly run through your connections and just give me the IDs of products liked by friends of my friends? This is what graphs are built for. It's lightning fast. Then it takes that small list of IDs, zips over to the biography shelf, and says, okay, now give me the full detailed profiles for all these product IDs, which is also super fast. Finally, it just combines the data, ranks it, and shows you the most relevant results. It's a perfect division of labor. And why is all this efficiency so critical? Well, it all comes down to sheer scale. A medium-sized app can easily have over 2.5 billion relationships. Trying to search through all that without a specialized graph database would be like trying to find one specific sentence in a library the size of a city with no card catalog. It's just not going to happen. So let's zoom out for a second. What does this all really mean? This multi-model architecture, it's not just some niche solution. It's a fundamental pattern for building the next generation of intelligent, personalized apps. Let's just quickly hit the key lessons here. The biggest idea is that the document database is always your source of truth. It's the master copy. The graph is just a specialized, derived copy, which means if anything ever goes wrong, you can just rebuild it from scratch. The Outbox pattern is so critical because it completely prevents those dangerous dual-write bugs that can corrupt your data. And of course, safety first. You absolutely have to put limits on how deep these graph queries can go, or you risk overloading the whole system. And putting all of these pieces together is what gives us the incredible recommendation engines and social feeds that we use every single day. And that kind of leaves us with one final fascinating thought. We've seen how this architecture can map billions of connections in real time. So if an app can truly understand this complex web of relationships between you, your friends, and everything you're interested in, what kind of genuinely intelligent features are we going to see next? It's pretty exciting to think about. Thanks for digging into this with me.